Okay, so I want to talk about how through Faraday's law we can explain how we can take a normal wire, normal coil, and induce an EMF in that coil, therefore producing a current. So with Faraday's law, the induced EMF is equal to the negative amounts of turns in the coil, that's the N, times by the change in magnetic flux divided by the change in time. And then magnetic flux is represented here by the strength of the magnetic field times by the area of the wire, and then the angle between like the normal of coming out from the wire and the angle of the magnetic field. So there's essentially, according to this equation, 3 different ways that we can induce this EMF in our wire. The first one is through the magnetic field. So if we take a magnet, while it is stationary, there will not be an induced EMF in the wire. There needs to be a change, right here, a change in the magnetic flux in order to produce that EMF. So as we move this magnet in and out, or across, or any movement, any change, then we will induce an EMF and therefore current in our coil, in our wire. The second way that we can do this, according to the equation, is by changing the area. Because if we change the area, therefore it'll change the magnetic flux, giving us an induced EMF. So in this way, if we somehow stretched out our wire so that it contained a bigger loop or more area, we could then induce an EMF also in our wire. Then the last way is, let's say that we're looking at the wire from a side view. So that we've taken this and then folded it flat, so it's in the board. The angle we're talking about, let's say we'll say the magnetic field is going, we'll just say it's going down like this, okay? So the angle between the normal from our wire and the magnetic field, if we can change that, let's say that we rotate like this, the magnetic field is still going the same way, but since we've changed the angle here to this, we can then induce an EMF in our wire. And that's Faraday's law. So thanks.